Okay, so yesterday we said that our first step was getting y by itself in at least one of the equations. So as we look at problem number 1, we already have an equation that is y equals. So we're good. So we can move on to that step 2. And step 2 was replacing, change colors there, hold on, was replacing the y with this part from the other equation. So I'm going to rewrite this as x plus 3x equals 8. And now I'm going to solve for x. So the first part of solving for x would be combining these like terms to give me 4x equals 8, which means x equals 2. So that is my x value in my ordered pair, 2. Now I'm going to find my y value. To find my y value, I'm going to take this 2 and I'm going to replace the x with the 2. So I'm going to use the easiest equation with the y already by itself. So that's going to be y equals 3 times 2, which is 6. So the 6 is my other value, my y value. Questions about this problem? Okay, question number 2 then. Again, my first step is to look to see, do I have any of them that are y equals? And I do. So I can automatically go ahead and replace this y with this x plus 3. So I'm going to rewrite that equation as 2x plus 2 times x plus 3, and that's going to equal 38. I want to solve for x. I see parentheses. This is going to mean that I need to distribute. I need to distribute this 2 to the x and to the 3. So that's going to give me 2x plus 6 equals 38. Combining like terms, that's going to give me 4x plus 6 equals 38. Subtract 6 from each side, that gives me 4x equals 32. So that means x equals 8. X equals 8. So again, going back up to one of these equations and replacing the x value with the 8. So I'm going to choose this easy equation here and say that y equals 8 plus 3. So that means y equals 11. So your ordered pair is 8, 11. Questions? All right, and then we have our last system. I don't know if you noticed in the second equation, but there wasn't an x. That kind of made it confusing for some people. So this first equation is already written with y by itself, so we're good to go on to the second step. I'm going to replace the y down here with this 8 minus x. So I'm going to rewrite it. 7 equals 2 minus, now this is where some people messed up yesterday, 2 minus 8 minus x. You are going to have to distribute that negative sign. Some people just went ahead and just left it 2 minus 8 minus x, which will give them the incorrect sign in their final answer. So look to see, did you distribute this negative sign? I think, again, this was the trickiest part of this problem. You have to say negative times the 8, which is a negative 8, and a negative times a negative x, which would give you a positive x. Yep, a lot of people didn't do that, and so that was the trickiest part again. You'll get the wrong answer if you don't. Remember, the sign in front of something goes with it. So this minus sign, we have to really think of it as being a negative sign. This negative sign was attached to that y, a negative y. So if we're saying y is this whole thing, then it's a negative of that whole thing, not just a negative 8. Okay? All right, so now we can combine like terms. So 2 minus 8 is going to give me negative 6. Then I'm going to add 6 to each side. So I get that x is 13. X is 13. So coming back up here, obviously I can't plug x into the second equation. I'm going to have to use this first equation. And if I'm saying that y equals, instead of 8 minus x, 8 minus 13, then that means y has to be negative 5. So your final answer should be 13, comma, negative 5. Okay? Alright, I want you to hold on to that paper because I'm going to have you do something like either on the back of it or at the bottom of it, whatever you have space for. But why don't you go ahead and get your notes back out. And if you don't have space for notes, then you can come get another piece of paper. We are not going to be taking as big of notes as we did yesterday, don't worry. You've done the hardest. Okay, so far, every system that we have had so far, whether it was when we were graphing or when we were using substitution like yesterday, every system so far has had one solution. And most systems will have one solution. But it is also possible for a system to have no solution. And it is possible for a system to have infinite solutions, which also means all solutions, yes. So again, the system can have one solution, no solution, or an infinite number of solutions, which is also called all solutions. So we are going to talk about, we know what one solution looks like. We find that one solution by graphing. How do we know where the one solution is when we graph? Where the two lines meet, where they intersect, okay? And then we just did it yesterday with substitution, and that gave us one solution, one ordered pair. No solution, if one solution would be where the lines intersect, then no solution would mean what? Where they don't intersect, and a couple people threw out the word parallel. Good. All right, so if it's no solution, it means the lines are parallel. So again, if it's no solution, it means the lines are parallel. Do you know how you could look at two equations before graphing, just looking at the equations, how you would know if they were parallel? Emily? Same slope. But they're going to have a different y-intercept. So again, it's going to be no solution when the lines are parallel. We're going to know the lines are parallel if they have the same slope but a different y-intercept. So let's do an example that would be considered no solution. So if I gave you the system y equals 2x minus 1 and 3y equals 6x minus 5. Right now we can't really tell, I know some of you are doing the calculations in your head, but we can't really tell what the slope is in the second equation until we do what? All right, so we need to get this y by itself first. So we're going to divide each of these terms over here by 3, and that would give me y equals 2x minus 5/3. So in each of my equations, the slope is 2. The y-intercept, they are different. So because the slope is the same and the y-intercept is different, if we were to graph these, which I'm not asking you to, if we were to graph them, then the answer would be no solution. These lines would never cross, no matter how large your graph was. Emma, question? Yes. All right, so any questions about no solution? All right, so then let's talk about all solutions. So all solutions or infinite solutions basically means it's the same line. Okay, so infinite solutions. Again, basically it means it's the same line. It's going to be the same equation, same exact equation. Now they're not going to look exactly the same because they're not going to be given to you in y equals mx plus b form. But once you turn them into y equals mx plus b form, slope-intercept form, they're going to look exactly the same. So again, they're going to have the same slope, same y-intercept. The same slope and the same y-intercept. So let's do an example of one of those. If I had y minus x equals 5, and I had 3y equals 3x plus 15. So right now, these don't look similar at all. Okay? But if we change them so that they're y equals mx plus b form with slope-intercept form, then we will see that they really are the same. To change this first equation into slope-intercept form, what would I do? I would need to add x to both sides, so then I could rewrite this as y equals x plus 5. And then if I was going to rewrite this one, I would divide by 3. And again, dividing both of those terms on my right by 3, and that would give me y equals x plus 5. Once I simplify, right? 3 over 3 equals 1, 15 over 3 equals 5. So they are exactly the same, so my answer would be infinite solutions, because they're exactly the same. So if I were to graph these, it would just be one line on the graph. Okay? So the options are you have two lines that intersect, that would be one solution. You have two lines that never intersect and are parallel, that would be no solution. Or you just have the same exact line, and that would be infinite solutions. So what I'm going to do is I'm going to write 6 systems up here, 6 systems, and this will go on to that paper that you did those 3 problems on from last night. Okay? So this requires no graphing whatsoever. I am not looking for, if it's one solution, I don't need to know what is that one solution. The only thing you're telling me is it one solution, no solution, or infinite solutions. So again, you're writing down the question, writing down the system. If it's not in y equals mx plus b form, you're converting it to y equals mx plus b form. And then you're saying one solution, no solution, or infinite solutions. You can just say one, no, and infinite. Okay?